Next we have the permutation 2. This is nothing but the continuation of the session 1 of the permutation 1. There we are seeing the basic set of problems. Here we'll be seeing the second type of problems under the permutation 2. So let us go directly to the example. The example 1 is nothing but find the number of permutations of the letters of the word M, A, S, S, A, S, A, U, G, A. First you have to find the number of permutations of this word, and then in how many of these all 4 A's are together, and then next question is how many of them begin with S. So first you have to find the number of permutation of this, then in how many of these all 4 A's are together, then how many of them begin with S. So here there are 3 set of problems we are supposed to solve. So first one is a basic problem which we had already solved in the previous session. So same way let us write this word as it is. So that is M-A, S, S, A, S, A-U-G-A. Okay, we'll write as it is. The given word has 10 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. So just write the given word has 10 letters, of which 4 are A. Just see how many are more. 4 are A, and then you have 3 S, 3 are S, and 1 each of M, U, G. M, U, G. You can see 2, 3 S, 1, 2, 3, 4 A. So 7 letters are done. 8, 9, 10. That is of 1 each. So let us write this. This is done. Now we'll see. Find the number of permutations of the letters of the word. This word. So this actually contains 10 letters. So the number of permutation, the required number of permutation, the required number of permutations is equal to 10 factorial divided by repetitions. 4 are A, so 4 factorial, 3 factorial, 1 each of MUG, so 1 factorial, 1 factorial. So all those factorials you should mention. Okay, even if it is 1 factorial also you are supposed to mention. So 1 factorial of M, 1 factorial of U, 1 factorial of G. So it is 1 factorial of M, 1 of U, 1 of G, and 3 of S and 4 of this. So the answer is, when you calculate, you will get the answer as 25200. So this is the number of permutations of the letters of the word M-A-S-S, A-S, A-U-G-A. So this is of the word this, and we got the first solved. Next, in how many of these all 4 A's are together? I'll try to solve in the next page. I'll just write the word as it is. That is M, A, double S, double A. Sorry, no. It's nothing but M, A, double S, A, S, A, U, G, A, A, U, G, A. So this is the word. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of this we had 4A, 3S, and then we had UG, M, U, G, we had 1. Okay, so the second question we had was, in how many of these all 4 A's are together? All 4 A's are together. All 4 A's are, all 4A, all 4. In how many of these all 4 A's are together? If that is the case, how many A's are there? 4 A's are there. Okay, all 4 A's are together means that 4 A's we are taking it as a single block, one particular block. Remaining all all 4 A's are together. Remaining is how many? If it is 4, remaining is 4 A's, remaining letters are 6, right? 6, out of which 3 are S and remaining is this. This 4 A's is together, taken as, this will be taken as one block and this will be taken as 6. 4 A's are together and this is taken as a single block, and since again there is no need of permutation of A's within themselves, because A's meaning is same, right? A's is same. So the solution is, here I'll write, if in a permutation, if in a permutation, all A's are to be together, we treat all of A's as one single letter, Then letters to be permutated read as number of, hence the number of permutation is nothing but this is together, so it is taken as 1. Remaining, you know, there were 10 letters. If 4 A's are taken together, then this is 6. So total number of permutation, therefore the number of permutations is 9 factorial divided, is 6 plus 1, 7 factorial divided by A is taken as single block. So if it all 4 A's, see, second question is all 4 A's are together, they are taken as single. That means appearing way, how they will appear is 1, 2, 3, 4. All 4 A's are together, and then for example S, M, U, G. Okay, all 4 A's are together, they have given a condition. If all 4 A's are together, they have taken, then this is considered as 1 factorial way. So for A it is 1 factorial, for S again it is 3 factorial, for M it is 1 factorial, for U it is 1 factorial, and for G it is 1 factorial. So this is nothing but 840 is the answer. You might get confused, like there are 4 A's they have mentioned, all 4 A's are together. This is a single block. So if it is taken as together, means it is considered as only one single term. All 4 A's are together, one term. So no need to divide by 4 factorial ways. And you might think why these are not arranged within themselves, because letter is same. Now for example, there we had mathematic books, right? So that maths books might be anything. One might be DMS, one might be GTC, one might be M1, M2, M3, M4. Your letter A meaning is what? Same. So, and they have told that all 4 A's are together. So it is 1 and remaining this 6. So it was 7, and for that A's together is considered as one single term. So it is 1 factorial. So this is regarding the second sub question. The third sub question is how many of them begin with S. So I'll write over here. I'll write in a new page itself. Third one was how many of them begin with S. So you know that we had A4, SS, we had SS3, I guess, SS3, and then we had M, U, GS1. How many of them begin with S, they have told. So if SS out of the 10, if it has to begin, remaining places are how many? 4, this is 5, 6, 7, 8, 9. So there are 9 places. How many of them begin with S? So already S is occupied over here. Remaining, how many of them begin with S? Let us take S over here, that has been occupied. Remaining, how many places I need to arrange? N. So that is N factorial. Beginning with S, they wrote N factorial. And then you see repeated terms over there. A is 4 factorial. Out of 3 S's, 1 is already been occupied. So it is 2 factorial over here. And then it is 1 factorial of M, then 1 factorial of U and 1 factorial of G. So this is the answer for the third sub question. The answer will be 7560. Don't get confused over here. So they have told that how many of them begin with S. So I gave S position over here. 2 S's are there. Those 2 S's can occupy in any of these places, and then 4 A's can be occupied and MUG. So remaining places is 9 places. So 9 factorial divided by 4 factorial of A. Why it is 2? Because 1 S is already been occupied. Then 2 factorial and 1 each factorial of these. So the answer is 7560. So this is regarding the example 1. Next, let us go to the example 2. How many arrangements are there for all letters in the word sociological? How many arrangements are there for all letters in the word sociological? So let us solve this first section. A, let us take it as A. So the word is sociological. SOIOLOGICAL. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 letters. How many arrangements are there for all the letters in the word sociological? So that is nothing but 12 factorial. N is 12. Let us see how many times S has been repeated, how many times O. So we'll write from increasing order. So if you see O is repeated thrice, okay, and C, comma I, comma L is repeated twice. You can see C2, L2 and I2. Okay, C, I, L is repeated twice. SAG, S, comma A, comma G is repeated one time. Okay, so 12 factorial from increasing order if I go, divided by 3 factorial of O, 2 factorial of C, 2 factorial of I and 2 factorial of L, and 1 each factorial of S and 1 factorial of A and 1 factorial of G. So if you see that 3, 2, 2, 2, 1, 1, 1. So this is the nothing but the number of permutations of the word sociological. So you should write that the given word, you need to mention that the given word has 12 letters, of which 3 are O, 2 each of this and 1 each of this. Therefore the number of arrangements of these letters, therefore the number of arrangements of these letters, is 12 factorial divided by 3 factorial divided by 2 into, answer is nothing but 9979200. Okay, 9979200. So this is the answer of the example 2. First part, example 2, first section. Next they are told in how many of these arrangement A and G are adjacent. So let us solve that particular problem in next page. A and G are adjacent. Second is in the sub question of that. Second one is how many of out of this A and G are adjacent. A and G are adjacent. Okay, A and G are adjacent. In this, if you see again, I will write how many times that is been repeated. 3O. 3 times O is been repeated, 2 each of C, I, L, C, comma L, and 1 each of S, comma A, comma G. Let it be here itself. A and G are adjacent. So if in an arrangement A and G are to be adjacent, we treat A and G as a single letter. Okay, if we want A and G as adjacent, out of total we have 12 letters, right? 12 letters. If you want A and G as adjacent, A and G can be adjacent in one in this way or one in this way. We treat it as a single combination. So this single combination is 1 out of 12. 2 is gone, the remaining is 10 arrangements, and this is taken single, so it is 11. So it is 11 factorial. Why? This we took single, but in the previous case it was, if it was AA, we took it as single block. Further there was no arrangement between these AA, but here we have, you can have AG, next form you can have GA. So this you have to remember, GA. So here A and G we take it as a single block. Okay, fine. So out of 10, 2 letters are gone and it is considered as 1. So it is 1. Remaining out of 12, 2 letters are gone and this is considered as 1. let it be over there. Remaining is 2 is gone, remaining is 10, and this is taken as single, so it is 10 plus 1, it is 11 factorial. 11 factorial divided by a and g is taken as single, right? So your a and g is appearing here, rest all it is appearing same, right? So it is 3 factorial of O, 2 factorial of C, and 2 factorial of I, and 2 factorial of L, and 1 factorial of S, and for this also you are taking single itself, so it is 1 factorial. There is no 1 extra factorial. You should write all these factorials because it's very important. Why I missed one of this? Because this I took it as single form. So this is when it is in the form of AG. It is in the form of AG. A and G are adjacent. Now, when it is GA, what will happen? GA, what will happen? Same thing. Same thing. So it is same formula. But what we have to do? We have to sum it up. So we'll just write this. When it is these many ways. When it is A and G are adjacent, these many ways. So just write. I'll just tell a statement over here. You just need to write. If in an arrangement A and G are to be adjacent, we treat A and G together as a single letter. A and G are adjacent. We treat A and G as a single letter. I'll write over here. If in an arrangement, A and G are to be adjacent, A and G are to be adjacent, we treat A and G together as a single letter. Say X, let it be X, so that we have 3 O's, 2 each of C, I, L, and 1 each of S and X. While X is nothing but taking A and G together. Okay, 1 each of X. So totaling how many you just total here? 3, 4, 5, 6, 7, 8. Okay, 9. Sorry, wait. 3 O's. Okay, 3. 2 each of this. 2 into 3, 6, 7, 8, 9. 10. 1 each of 10 and X. So total it is 11. So therefore, totaling to 11 letters. Okay, these can be arranged in 11 factorial divided by 3 factorial, 2 factorial, 2 factorial, 2 factorial, okay, of, and then 1 factorial of S and 1 factorial of AG. These many ways. This was when it was AG. Further, the letters AG can be arranged among themselves in 2 ways, right? That is, AG can be arranged themselves in 2 ways. That means AG or GA. So that's why we have to multiply that with further the letters A and G can be arranged among themselves in 2 ways. Therefore, the total number of arrangements is nothing but 11 factorial divided by 3 factorial, 2 factorial, 2 factorial, 2 factorial, same right, 2 factorial, and 1 factorial, 1 factorial into 2, that is equal to 1663200. Why this 2? This was for AG, one more is for GA, or else you can just, this is one way when it is AG, for GA also this is same, this plus this, or you can directly multiply by 2. When it is AG it is this, when it is GA also it is this. So either you can do this plus same term, or you can just multiply 2. So this is the required results for the Second question. Last they have told all the ovals are adjacent. All the ovals are adjacent. So I'll write again in the new page. Sub question is all the ovals are adjacent. So in the sociological ovals we have as A, O, I. These are the ovals we have. If in an arrangement all the ovals are to be adjacent, that means A, O, I needs to be in adjacent. All these ovals are to be adjacent. We'll write first how many were there. So we out of the total 12 letters we had 3 O's and 2 each of C, I, L, and 1 each of S, A, G, 1 each of S. So here we have an oval, here we have 2, and here we have 3. Okay, so in this sociological, I'll just first explain, then we'll write the statement form. So here we have 3, this O, I, and A, these should be adjacent. So these terms you will take it as one single term. Take one single term. How many A's we had? 1A, O we had 3, I we had 2. So it is totally 5, we are taking it as single. So 12 minus 5 is actually 1, A is 1, I is 2, 3, 2, A is 1. So if we take it as a single letters, we have 12 minus we have 7, right? 12 minus 5 we have 7. If in arrangements all the ovals are to be adjusted, we treat all them in the words as a single letter. So if we take this as a single letters, it is 1. This is 1. So O is done. 1 plus 2 C's, 1 plus 2 C's plus 2 L's plus 1 S plus 1 of G. So total it is 1, 3, 5, 6, 7. Yeah, correct, 7. It's not 12 minus 5. I think it is 12 minus 6. Why? Because 2C, 2L. Yeah. 2 C's we had, 2 L's we had, so it was 4. And S and G, it was 6. 12 minus 6 is 6 we got. And because 12 minus 6, these 6 letters, we got 6. So this we are taking it as one single term. Why? Because this is 1, 2, 3. 12 minus 6 we got 6, and this is taken as single. So we got 7. So that is 7, and then whatever the repetitions you are going to do, then arrangement of these ovals again needs to be multiplied. So this is the logic. So let us write in terms of statement itself over here. Let us write the statement. If in an arrangement, all the ovals are to be adjacent. If in an arrangement, all the ovals are to be adjacent, we treat all the ovals present in the word, all the ovals present in the given word namely A, O, I as a single letter. Say Y. Let it be Y. Say Y. That is nothing but Y is nothing but A, O, Y. A, O, I. So that we have 2 each of C and L, 1 each of S, G and Y. 1 each of S, 1 each of S, G and Y, totaling to Y is nothing but this, okay? Totaling totaling to 7 letters. So this can be arranged in totaling, so therefore these can be arranged in 7 factorial divided by repetitions excluding this, because this is taken as a single term, right? Single term. So if you take excluding this, so what is for the 2 factorial form? So you are telling AOI as a together, AOI have taken together. So 1 2 factorial is of C. We have 2 each of C, 1 more is of L, 1 each of 1 factorial of S and 1 factorial of G and 1 factorial of Y. Y is nothing but AOI. Now again, these are what, all the ovals are adjacent, but again these ovals needs to be arranged, right? Ovals needs to be arranged. Further, I'll write here, this side I'll write, okay? This is one way of arranging that. Further, since the given word contains three O's, 2 I's and 1 A, they can be arranged. They can be themselves be arranged in how many ways? 3 plus 2 plus 1, that is 6 factorial divided by 3 of O, 2 of I and 1 factorial of A ways. Okay, so therefore the total number of arrangements of the ovals when they are adjacent is nothing but 7 factorial divided by 2 factorial, 2 factorial, 1 factorial, 1 factorial, 1 factorial into 6 factorial divided by 3 factorial, 2 factorial into 1 factorial. So answer is 75600. See here, this I have told all ovals are together. So this logic is clear, but these ovals should be rearranged within themselves. So you had 3 O's, 2 I's and 1 A. So that is 6 factorial divided by repetition of O, repetition of I and repetition of A. So this is the number of ways how you can arrange the word sociological when all the ovals are adjacent. So this is regarding the example 2. Example 3, how many positive integers n can be formed using the digit 3, 4, 3, 4, 5, 5, 3, 4, 5, 5, 6, 7. If we want n to exceed 5 lakh. Okay, if we want n to exceed 50 lakhs. So that is nothing 50 lakh. Okay, that is 5 followed by 6 zeros. 5 followed by 6 zeros. So what here n must be in the form of what? Here we have how many positive n can be formed by using these. So there are totally 7 digits. Okay, fine. But here n must be formed. Here n must be in the form n equal to x1, because 1, 2, 3, 4, 5, 6, 7 exceed. If you want n to exceed, right, this 5, that is 50 lakh, x1, x2, x3, x4, x5, x6, x7. n must be in the form of this, right, because it should exceed 1, 2, 3, 4, 5, 6, 7. If you want to exceed, then x1 should be either 5 or 6 or 7, right? If you want n to exceed this, so n can be either 5, n can be either 6, first x1 can be either 5, x1 can be 6 and x1 can be either 7. Remaining is what? It can be any of these digits. So how many positive integers n can be formed using the digits they have told. So if you put 3, it cannot exceed. If you put 4 also, you cannot exceed. You should either put 5 or you should either put 6 or you should either put 7. So out of this you just write here 3 is repeated once, 4 is repeated twice, 5 is repeated twice, 6 is repeated 1 and 7 is repeated 1. So x1 can be either 5, either 6, either 7. So what you have to do is, when n is equal to x1, what is the arrangement you have to find? When n is equal to 6, what is the arrangement? And when n is equal to when n is equal to this form, when x1 is equal to 5, what is the arrangements you will get? When x1 is equal to 6, what is the arrangement? And when x1 is equal to 7, what is the how many arrangements you will get? Finally, since x1 can be either 5 or 6 or 7, we should use what? Since it is OR, we should use sum rule. So when x1 is equal to 5, you will get certain number of ways. When x1 is equal to 6, you will get certain number of ways, and when x1 is equal to 7, you will get certain number of ways. Finally, you have to add all these ways, and that is what the number of ways the positive integers n can be arranged. So let us try to solve. Here n must be in the form of n is equal to x1. Write it in this way, where x1 to x are the digits with x1. These all are nothing but the digits, okay? With x1 equal to 5, 6 or 7. Suppose now we'll take suppose we take x1 is equal to 5. Then what will happen? If we take x1 is equal to 5, remaining how many ways, how many are there? 6. So that is, suppose we take x1 is equal to 5, the number of arrangements you will write. The number of arrangements is, suppose we take x1 is equal to 5, the number of arrangements is equal to 1, 2, 3, 4, 5, 6, 6 factorial. Check how many times it is repeated. I took 5, one fixed position as 5. So 4 is been 2, 5 is also 2. So write that greater 2 factorial, this is of 4. 5, 1 is fixed, 1 is left. So 1 factorial of 5. Then 6, 1, 7, 1, 3, 1. So it is 1 factorial of 6, 1 factorial of 7 and 1 factorial of 3. So it is nothing but 6 factorial divided by this. When x1 is equal to 5, this will be 1 factorial because x1 already occupied with the 5, remaining is 1, and this 2 factorial is of 4, then remaining same method. So answer will be 360. Okay, this is for x1 is equal to 1. Suppose same x1 is equal to 6. When we take x1 is equal to 6, I'll write double quotes, that is same repetition of this. Number of arrangement is what? When x1 is equal to 6, when it is 6 over here, remaining is what? Again 6 factorial, right? 6 factorial divided by 6 factorial divided by, here x1 is 6, here 6, remaining 6 position, 1, 2, 3, 4, 5, 6. So that x1 6 is been occupied. Remaining is what? This should be divided, this should be divided, this should be divided, and this should be divided. So that is nothing but 2 factorial of 4, 2 factorial of 5, 1 factorial of 3 and 1 more factorial of 7. Answer is nothing but 180. So this is for x1 is equal to 6. Similarly, when you have x1 is equal to 7, then write down the statements. I am not going to write over there. When x1 is equal to 7, instead of 6 we have 7 over here. 7 is also 1. So it is nothing but again remaining 6 we have to arrange. So 6 factorial divided by 2 factorial, 2 factorial, 1 factorial of 6 and 1 factorial of 3. So again it is 180. Since it is, we take with x1 is equal to 5, 6 or 7, since it is OR case, finally the total number of arrangements, I'll write here, the total number of arrangements is, the total number of arrangement is nothing but 360 plus 180 plus 180, that is equal to 720 by sum rule. You know, when it comes OR, it is sum rule, by sum rule. So this is the answer for the example 3. Next we have example 4. Here they have told, find the value of n so that this is equal to this. You have to find the value of n. We have to apply the formula and try to find the value of n. So let us solve this particular problem in the new page. I'll write the question. Find the value of n so that 2p of n, 2 plus 50, n, 2 plus 50 is equal to p of 2n, 2. Okay, so 2p n comma 2 plus 50 is equal to p 2n comma 2. So over here, let us apply the formula for this, that is 2 into p of n comma 2 is nothing but n factorial divided by n minus 2 whole factorial plus 50 is equal to here 2n whole factorial divided by 2n minus 2 whole factorial. Okay, so here I will try to solve in this way, like 2 into n factorial, can I write it as n into n minus 1 into n minus 2? You know, like for example, if it is 5 factorial, meaning is nothing but 5 into 4 into 3 factorial, I can write nothing but 3 factorial is 3 into 2. Same way here I wrote n into n minus 1, so that I can cancel this n minus, here n into n minus 1 into n minus 2 factorial I have written, divided by n minus 2 factorial plus 50 is separate. I wrote this way, and this gets cancelled. Similarly here also you can write 2n into 2n minus 1, next minus 1, next 2n minus 2 whole factorial I can write, divided by 2n minus 2 whole factorial. So this and this gets cancelled. Remaining will be what? 2 into n minus 1 plus 50. 2 into n minus 1 into 50. Here also it will be 2n into 2n minus 1. So just try to multiply here. 2 into n is 2n. 2n into n is nothing but 2n square. 2n, it is meaning is nothing but 2n. 2n into n is 2n square minus 2n plus 50 of this. Here it will be 2n into 2n, that will be 4n square minus 2n. So minus 2n and minus 2n get cancelled. So here it will be 50 equal to 4n square minus 2n square. So 50 is equal to 2n square, and it will be nothing but 50 divided by 2 is equal to n square. So 2 ones are 25s are, n is equal to root of 25. So you will get n is equal to plus or minus 5. Since it is n cannot be negative, because we are finding the find the value of n, right? Cannot be negative. We are just taking the positive value. So the given, so therefore n is equal to, value of the n is equal to 5. So that's what he has told to find the value. Find the value of n. So since I cannot take the minus 5 as the n value in the factorial, so the value of n should be equal to 5. So this is regarding the example 4. Next is example 5. For non-negative integers n and r, if n plus 1 is greater than r, prove that this is equivalent to this. Okay, this is equivalent to this. Now what you have to do is, if you want to prove that, again you have to put a formula. What I'll do is, this formula is equivalent to this. What I'll do is, this division by this, I should get this answer. So let us try for non-negative integers n and r. We'll try in a new page. For non-negative integers n and r, p of n plus 1 comma r is equal to n plus 1 divided by n plus 1 minus r. Okay, n plus 1 minus r into p of n comma r. Okay, p of n plus 1 comma r is equal to n plus 1 divided by n plus 1 minus r into p of n comma r. So here, what I'll do is, this is what we are supposed to prove. What I'll be doing is, I'll just take this over here. I'll just find the value of, I'll just find p of n plus 1 comma r divided by p of n comma r. Let us find the value of this. Okay, let us find the value of this value. We should get this, right? So let us find the value by applying our formula. So what is p of n plus 1 comma r? It is nothing but, p of n plus 1 comma r is nothing but n plus 1 factorial divided by n plus 1 minus r factorial. Correct? No, n plus 1 factorial divided by n plus 1 minus r factorial. You know that p of n comma r formula is nothing but n factorial divided by n minus r factorial. Since here it is n plus 1, we instead of n we have n plus 1, so it is n plus 1 whole factorial divided by n plus 1 minus r factorial. This whole divided by p of n comma r. What is p of n comma r? It is nothing but n factorial divided by n minus r factorial. N minus r factorial. This, if I want to equate, what it will be, n plus 1 whole factorial. This I can write it in n plus 1 whole factorial divided by n plus 1 minus r factorial. I wrote as it is. If I take this above, it will be nothing but r will be above, that is n minus r factorial over here, and then n factorial over here. Okay, so what is n plus 1 divided by this? So if I want to find the next term of this, next this and this I can get cancelled, so it is like n plus 1 into n plus 1, next term n plus 1 minus 1, right? Next term is n plus 1 minus 1 divided by here I can write I can write it as n plus 1 minus r, n plus 1 minus r into n plus 1 minus r minus 1 is factorial as the next term. Here I can write it as, this is how I wrote for this and this. Okay, here I missed one factorial for this. n plus 1 minus 1 of this and n plus 1 minus r into same as it is of this. So it is n minus r factorial and then n factorial. So I'll write here, over here, this is nothing but n plus 1 into n plus 1 minus 1 is nothing but n factorial divided by n plus 1 minus r. N plus 1 and minus 1 gets cancelled, so it is n minus r whole factorial into n minus r factorial divided by n factorial. So what is this? This n and this n cancels, and this n minus r and this n minus cancels. So we got n plus 1 by n plus 1 minus r. So this continuation I will write over here. So we got p of n plus 1 comma r by p of n comma r is equal to n plus 1 divided by n plus 1 minus r. This is what we got over here. So what is there over here? Just this has to go to the right hand side. So what is that? P of n plus 1 comma r is equal to nothing but n plus 1 divided by n plus 1 minus r into this denominator. I took it to the right side, so it became p of n comma r. So by this we proved that p of 1 n, this is what we are what was required. So p of n plus 1 comma r is equal to n plus 1 divided by n plus 1 minus r into p of n comma r. So we proved left hand side is equal to right hand side for non-negative integers n and r. So this is regarding the example 5. This is the end of the permutation. Thank you.